Hello, my name is Sayed Zain, and in this video I will be presenting a detailed summary and analysis on the paper titled Big Data, Fast Data and Data Lake Concepts by Natalia and Alexandar. Let's begin by looking at the current state of enterprise data. In today's time, IT systems are able to capture a very huge amount of unstructured data. The rate at which this data is captured is also very high. This type of data is referred to as a data stream, where the data is dynamically changing. Time-critical data streams require immediate processing with very minute room for delay. Prominent examples are of network traffic, video surveillance, and also data being generated by IoT devices. So let's define big data now. Any dataset that is beyond the storage and processing capabilities of a standard in-home computer or software like Microsoft Excel is called big data. This might seem like a loose definition, but it holds prominence. Big data is famously characterized by the 3 V's. Volume refers to the high scale of data. Most US companies nowadays have around 100 terabytes of data. Variety refers to the type of data. Unstructured data is data that doesn't have a model, for example, videos or audios or text such as tweets. This type of data requires heavy processing before it can become useful. Structured data is organized and can fit easily in a database model. Spreadsheets are an example of a simple structured data set. The third V is for velocity, the rate at which data is being generated. 4 additional V's have now been added since then. Processing of big data is done through either of these 3 famous techniques. Batch processing is done when requirements are not time critical. Data is usually retrieved from non-volatile storage such as hard disk drives for this purpose. This technique works best for obtaining high accuracy from predictive models. Stream processing is done when results are required promptly. Data is directly taken from volatile memory for processing. If the processing rate does not match the data stream rate, data loss will occur. Hybrid processing combines both the earlier mentioned techniques. Its 3 underlying principles are robustness, data immutability, and recomputability. This is applied through a 4-layer architecture. The batch layer holds the master data set on a distributed file system, and it generates batch views. The serving layer holds the batch views in the data store. The speed layer deals with newly received data and compensates for the delay of the previous 2 layers by making the real-time views. The combination layer allows for synchronization. The next term we're talking about is data lake. These first 2 points are considered as the general definition for a data lake. A large-scale repository that stores data in its native format, whether it's raw data or videos or texts or whatever. This repository should be capable of growth when necessary. Processing tools used with data lakes do not modify the data structure. They are usually dynamically designed as opposed to data warehouse and analytical tools. Data lakes are designed to handle a large flux of unstructured data. Each data element in the lake has a unique identifier and a metadata tag associated with it. Looking at the architecture in more detail, we notice that it is flat compared to the hierarchical structure of data warehouses. There is a semantic layer present to provide meaning to the data and highlight its relations with other data in the lake. The technology being used is borrowed from the concept of internet hyperlinks. Data lakes are usually divided into zones to improve performance. One approach for division is based on how old the data is. So for example, all data that is less than 6 months old can be placed in one zone. Data that is older but still active can be placed in another zone, and archival data can be put in a third zone. Perhaps the most popular approach for division is shown by this image here, where we have a Hadoop cluster as a data lake. In this representation, raw data is sent into the raw zone. This is the equivalent of a landing area. The gold area is where the data is curated. This is the equivalent of a data warehouse. The work area is where data scientists or business analysts will use the data according to their need. The sensitive area has data that should not be accessible to normal users and should have high governance. An example of this is someone's bank account number. A data lake is said to have the following characteristics. 1. It should be scalable. It should be able to grow and adapt. The second is that there should be governance of the lake. Some mechanism to keep things checked. Data that is no longer of use or has been stale should be retired. The third characteristic is that a centralized indexing and a cataloging system should be in place. Cardinality means how data is related with other data in the lake. It is worth noting that the first three characteristics help prevent a data lake to turn into a data swamp. A data swamp is when a data lake no longer holds any usable information and becomes a waste. The fifth characteristic is the tracking of data and all the operations done on it. The source of the data and its potential use should also be present. The sixth and perhaps most important characteristic is that a data lake should have a single data store. Nixon, the person that first presented the idea of a data lake, followed up on the analogy. He said that a data mart is like a pre-processed bottle of water. A data lake is the opposite of a data mart and a data silo. It is a single storage area. Another prominent characteristic of a data lake is that data is never relocated for processing purposes. Furthermore, data lakes should be efficient by performing compression and removing redundancy and establishing quality of services. Data lakes should be capable of performing quick analysis as well as detailed subject analysis. Data lakes can consist of data from sensor inputs and logs, clicks on a website, social media data, geolocation trails, documentation, and all sorts of unstructured formats. The definition of fast data is based on these first 2 points. It is a data stream that requires immediate attention. To handle fast data, one must have a streaming system capable of sustaining high throughput and a data store that is capable of processing the data while maintaining the rate of throughput. Fast data processing is described using 3 key phrases. Ingesting is the input of millions of events per second by the system. Decision is the ability to make data-driven decisions on each event. And analysis is finding out trends in real time based on that data. In today's time, consumer-based enterprises are finding themselves in the midst of a fast data era, where they are potentially wasting valuable data just because of no mechanisms to store and process it. Some applications of fast data that come to mind are smart surveillance systems that can react instantly based on input from live CCTV footage, smart grid systems that could manage power supplies instantly, and also smart health management systems that can be placed in hospitals. Finally, let's try to link the 3 terms that have been the center of this paper. Data lakes are essentially an architecture or an abstract model that will allow big data management properly. Data lakes will combat the challenges of big data by storing metadata and forming semantic models to gain valuable insights from data, applying agile or detailed analysis whenever required. Fast data, on the other hand, is on the same wavelength as big data. Their link is the V in velocity. If big data is being generated at a high enough rate and requiring real-time processing, it becomes fast data. If fast data is being generated in a large enough volume, it becomes big data. Systems and architectures that were designed to sustain slow-moving big data are now shifting towards big data and fast data. Thank you.